Hi, this is Andy, and we're back with another video about integration techniques, and today we'll be covering integration by partial fraction. So in this first example, we could see that substitution doesn't really work. It would leave x in the numerator, and for substitution, we really want to just clear out all of the original variable. And integration by parts really doesn't work here because there's not really two parts to this problem. So the way we do this is by taking this fraction out, and do something called partial fractions, which is not really an integration technique per se. It's more of breaking up the fraction so we can integrate it using this. I'll explain it more as we get through it. So we can break x squared minus 4 to x plus 2, x minus 2. And now we can break it into two different partial fractions. So the first one is a x plus 2. The second one is b x minus 2. And let's say if you had another one, let's say like you had like x minus 3 or something, you would add on c x minus 3 and so on and so forth. But we don't have that. So we're just going to roll with what we already have. So we're going to simplify it down, or we're going to get rid of this denominator on this side. And by getting rid of this denominator, we got to multiply. And multiplying one side means we have to multiply the other side. So let's go ahead and write this down. Okay, now let's multiply. X minus 2. And then multiply the other side as well. So x plus 2, x minus 2. Okay, so this cancels. And for this, x plus 2 cancels, but now a gets x minus 2. This side, x minus 2 cancels, but x plus 2 stays with the b. So now, rewriting this, we get 12ax minus 2a plus bx plus 2b. But I want to make it more easier to see on the eye by combining like terms. So 12 equals a plus b times x plus negative 2a plus 2b. So now we could see that the blue part equals the constant value. But what does a plus bx equal? Well, this is basically the same thing as 0x plus 12, because 0 times x, that doesn't really exist, but we're putting that as a placeholder there, so we have something set up right now, which is called, which you guys should be familiar with, is systems of equation. It's not 0, that's 12. Okay, so we now have a systems of equation, but we want to cancel out some part of like one of the variables to make it easier to solve. So I'm just going to multiply the top by 2. So now we have 2a minus 2a, so that just equals no a. Next one's 2b plus 2b, it would equal 4b. 2 times 0, 0, and then bring down 12. So b equals 3. And now we'll just plug it back in unless you really want to solve the equation again, but I really don't want to, so we're just going to plug it back in again. 2a plus 2. Now b equals 3, so 2 times 3 equals 12. 2a plus 6 equals 12, so just move it to the other side or subtract it. We get negative 2a 6, and then we divide it by negative 2, and then a, it turns out to be negative 3. And this checks out because negative 3 plus 3 equals 0. So the first integration by parts, or the first systems equation checks out. So let's plug it back in. So 12x2 minus 4 dx. And basically we're saying that this fraction equals the same thing as this partial fraction. So the integral of a, so a equals, let's see what a equals again, negative 3. So a equals negative 3 x plus 2 over x plus 2 plus, now we plus b equals 3. So 3x minus 2 dx. Now you might be thinking, how do we solve this? Well, we're going to break it into parts. So the integral of negative 3 x plus 2 dx plus the integral of 3x minus 2 dx. Okay, so now we got this. And this is way easier to solve than the integral that we had before. So from this, we can get negative 3 ln x plus 2. If you don't see it, I'm going to show it. So this is basically the same thing as negative 3 integral of 1x plus 2. So the integral of 1x plus 2 would just equal ln x plus 2. So the next one would be 3 ln x minus 2. And then don't forget the plus c. So this is our answer. Okay,